All right, so in Unit 5 here, Chapter 5, we are talking all about, financial stuff in this unit. In reality, which if you will be a business major, you will find out, in reality, we don't end up using formulas and doing like math by hand for this kind of thing. They have Excel spreadsheets. They have other programs that they use. I don't have access to all said other programs, but I was able to find out how to do this all on your calculator, which if you had done this like 2 years ago with me, you might have cried at the amount of formulas that you had to like know when to use which one and how to solve them. And then I taught myself how to do all that on the calculator, and life was just much easier. So that's what we're going to do today. So what we're looking at under here, and you can kind of see the calculator there, but I want you to more see the screen, so I have the little button things minimized. But what you're going to look at in your calculator is the apps. And you may not have ever looked at the apps on these calculators, but you're about to. So if you go under the apps, there is a finance app, and it's the first one there. Yay! So everyone find the apps button. And under the apps, we are going to use finance. And there's lots of options under the finance solver. We'll talk about a couple of them, but not all of them. The main one we are going to use is that first one, TVM solver. Okay? And so before we ever get started on any of this, I just want to go through what is what on this. So in this TVM solver, I have mine with like numbers in it because I've used it now. Most of yours will have like nothing in it. Yeah? All zeros? Is that where we're at? Okay. So it honestly doesn't matter what's in it right now, whether you have numbers or zeros. Someone else might have used your calculator. But we need to first know what each of these things mean. So on your notes here, take a minute and write down each of these letters, and we're going to talk through what each of these things mean. Okay? So for N, in this calculator, N is two things combined together in the calculator. N is the number of times compounded per year times, I'll do the little dot, times the number of years. Now, hopefully you have more room than I do right there, because that took a lot of space on mine, okay? N is number of times compounded per year times the number of years. So there's two things included in that. You will notice on this solver, I know we just did some of these formulas in the last unit. So in this solver, there is no T for time. That's because T is included in N, okay? So I, on this one, is your interest rate, okay? And as you can see under that I% there, it is as a percent. So while when we do the formulas by hand, we have to move the decimal place twice and put in like 0.07 instead of 7%, your calculator does that for you. So you are just going to put in what percent it is, 7%, 5%, whatever it happens to be. It is not as a decimal, okay? PV right there stands for present value. Typically, present value tends to be a negative number, okay? And here is why. Present value in the world of finance is what you're putting into this account. A lot of times this is an investment or a savings account or something like that. And so you are paying money into that account. So you are currently losing that money to get more money later. Like that's the point of it. So the present value will be a negative number, and it is typically what you were investing at the beginning. Okay? PMT is payment. For today's lesson, payment is not involved. Payment will come specifically with something called annuities. That will be day 2. So for right now, leave payment as 0. And if you ever don't need to use something, you can just put a 0 back in there. Okay? FV, you might be able to guess since the other one, this is future value. Future value should come out as a positive number because if you're not making money on this, that's a very bad investment, right? So future value is what money you get at the end of that investment or the end of that savings account. Okay? And then PY and CY. We will go into more detail on these later. This is for right now, for today. This is the number of times compounded per year. Okay. There are times that those will be different numbers. That is not today. Okay. And just kind of a programming thing for you to recognize. If I type, and you'll see this when we start typing. If I type a number into that P, I just call it PY and CY because I don't want to say the whole thing is like payments per year and compounded per year. But if I type a number into that PY, it will also change CY to the same number. On the flip of that, if you type a number in the CY second, that will just stay that number. So it is possible to type a different number in here and not have it change, but it is not possible to type a different number up in the PY one. Okay, whatever you put in the PY, it will make the CY until you change that. And then the payment, this will come up later. You may choose that the payment will be at the beginning or the end of the year or of the month. It depends on what you're talking about. For right now, that doesn't matter as long as we're not using anything about payment. But next class, we'll talk about that more. Okay, so the main thing that we are doing with this is just being able to identify what goes where and what we're solving for so that we can plug in all of our information and the calculator will solve it for you. Okay, so let's all take a look at number one. We ready? So on question number one, we are told, suppose that $500 amounted to $588.38 in a savings account. After 3 years, if interest was compounded semi-annually, what does that mean? Twice a year, every 6 months. Okay? Semi-annually is twice every month or twice every year. Find the nominal rate of interest compounded semi-annually that was earned by the money. So the main thing we need to know here is what are we just typing into these different things. Okay, so if I'm kind of going down my list, well, actually let's just go out of order. What is the $500? Do you think? That's the present value. That's what you are investing in this to begin with. And how are we going to type it in? We're going to negative 500. So I'm going to say PV is negative 500. I'll type that in a minute. This amounts to $588.38. What is that? Future value. And that is a positive number because we're getting that money back out. Okay, after 3 years, that's my time, but we don't have time. So what's that going to be incorporated into? N. So for N, I'm going to use both of these things. 3 years, compounded semi-annually means how many times a year? Twice, every 6 months. So what are we going to put in for N? 6. Now, here's the thing. That's some real easy math for you to do, 3 years times semi-annually. Sometimes it's like 365 for daily. Guess what? Your calculator does it for you. You don't actually have to do type in the exact number for N. So in N, if you just want to type in 2 times 3, you will then hit enter and it will just switch to 6. So if it's a bigger number where you don't necessarily want to do the math, it will do it for you. Okay? We would like to find what? The interest. So we would like to find I%. That's our question. And then last but not least, they say compounded semi-annually again, but they didn't really have to say that again. We just needed to know that PY, CY are both going to be 2 as well. Okay? So if I now take all of this information to my calculator, I'm going to go over here, and like I said, I'm trying to shift back and forth here so that you guys can see what you need to see. Okay, so I know N is going to be 2 times 3, and just so you can see, you type that in that way, hit enter, it will make it for you. Okay, I'm going to make I 0 because that's what we're solving for. So anytime you don't have something or that's what you're solving for, you make it 0. It'll change in a minute. Present value is negative 500. We're leaving payment alone. Future value is 588.38. Is that right? Yes? Yes. And we said it's compounded twice a year. So like I said, if you change this one, and I'll just show you this here. If I change that to 6 and hit enter, that's not our number, but if I hit it, or if I type that in, hit 6, it changes the other one to 6. Okay? So you don't have to do both. We just want both to be 2. We don't care about begin, end on payment right now. Now, here's how we do our solving. Notice there's like no equal sign or enter or any of that. So you go back up to whatever you're trying to solve for, because sometimes we'll solve for n, sometimes we'll solve for the future value, sometimes we'll solve for all the different things. We're going to go all the way back up now to I. You do alpha enter. So when you get back up so that I is highlighted, you do alpha enter, and it spits back out your interest rate at you. So on this one, we would say I is equal to about 5.5%. Okay? So on the next one, we have a little bit less information, but let's just look at it and see if we can figure stuff out for ourselves. Okay? So it says, at what nominal rate of interest, again, I'm finding interest, compounded yearly. What's compounded yearly mean? One time a year. Will money, let's just say, double in 8 years? Did they tell you how much you are investing? No. So here's the thing with that. It doesn't matter. As long as you pick a starting amount and an ending amount that doubles. So what are some of my options?
1 and 2.
1 and 2. $1, $2, 2 and 4, 100 and 200. I don't care. It will all work out the same. Good? Yeah? So if I go to start typing things in, we want to find the interest rate. So again, I'm going to make my interest rate 0 temporarily. We would like our investment to double in 8 years. So 8 years compounded how many times a year? 1. So I do 8 times 1, or just 8 because I'm smart enough to do that, yeah. And then I'm going to say, all right, let's make my present value, I'll just do -1, which means then my future value will be 2. I do also, at the bottom, have to change these 2 last parts to compounded yearly, which means each of them needs to be what? 1. And again, when I hit enter on that, it changes both. I scroll back up to the top, and I would like to solve for my interest rate. So again, what do we use to solve for the interest rate? Alpha enter. And we get 9.05%. I did PV as -1, therefore my future value was 2, but you could have picked anything you wanted as long as it doubled. So you could have done $100 and $200 or $1,000 and $2,000. Some of them will be easier to think of with different numbers, which we're going to see in part C. Okay? All right, so see if you can do part B. We now want our money to triple.
Something was going on.
What's the only difference then in part B?
You just changed 2 different.
Yep, I just changed my future value. So whatever I made my original one, if I made my original one -1, then to triple that, it needs to be what? 3. If I made it -2, it needs to be 6. If I made it -100, I need to be 300. You know, kind of get the picture there. And I would like to solve for my I again. So now notice this time I didn't change my I back to 0 because we haven't really done any calculations. So it's not using that I when I go to solve then. So I can leave the old answer and I can hit alpha enter and it will just give me the new interest rate. I got 14.72%. We good with that? So if we want our money to have a 60% growth in 8 years, what does that mean, really?
0.6.
Okay, it's a 0.6 increase. All right, so let's use an easy number. Let's say I invested $100.
160.
That means I get 160 back out. So sometimes with those percentage growths, it may be easier to do a different number. Like this last one, it was very easy for me to say, okay, so double is -1 and 2. Triple is -1 and 3. Well, you know what? 1 might not make sense to you for 60% growth. So change how you're thinking about it then. So this one, I might feel better saying my present value is -100. Therefore, my future value would be 160. So for the ones that are not that specific, you certainly can make up different numbers if a different number makes better sense to you. Does that make sense?
And then for this one?
So then we're going to say 160, and that has not changed about the compounded yearly or anything else. And we're going to go back, and we're going to solve for I a third time. Alpha enter gives me a new I value of 6.05%. All of these like together should make sense. Like doubling is more than 60% growth, so the interest rate is lower for this one than it would be for the doubling, and tripling would be even higher. Okay, so we got that 6.05%. Any issues so far? All right, let's take a look at example 3. What I'd like for you to do at this point is read example 3 and just see if you can kind of identify some of the information. Like I said, we're not going to do all of the examples. I felt the need to do all the examples when we were solving by hand because there was a whole lot more understanding that had to happen. Here, I need to do enough for you to know the differences and what you're solving for, and then I'll call it a day. Okay? I think I maybe after this one have like 3 other ones I want to do. That will be fine. Okay? So I know compounded quarterly, we've got our present value, we've got our future value. We go down, we change our compounding to quarterly is how many times a year? 4. What are we solving for in this one? We're solving for n. All right, now, there is one additional twist to this one, purely because of what it's asking. Exactly, good. So if I go and solve for n, what do we get for n? Do we get 27.23? Yes? Okay. So the one twist on this one is this. I've got n is 27.23, but remember what we defined n to be back when we wrote up what all these were? N is 2 things together, right? N is number of times compounded per year times the number of years. So that's not my number of years. So this, to get that number, I did number of years times, how many times were we compounding per year? 4. So to get the number of years and work backwards, I have to do what? Divide, right? So although it does mean that we have to quit what we're doing in here, remember to quit out of any program on your calculator. You do second quit, and I can do 27.23 divided by 4, which tells me about 6.81 years for my time. Issues with that? All right. I'm going to come back to a couple things on this page in a minute because that requires a different formula and, well, a different command. Remember that we don't actually need these formulas because we're doing everything in our calculator. So we'll come back to that in just a second. Let me just look at which other ones I want to do using that same solver. Give me just a second to look at that. So if I am reading in question number 9 here, we want to find what? Present value. All right, so this time, that is our question mark. Present value of $1,000. If we're finding the present value, what is 1,000? Future value. Due after 3 years. Okay, so we've got 3 years. And we are compounding what? Monthly. So what am I going to type in for n? 12 times 3, or 36. Yeah? Because remember, n is number of times compounded times number of years. Okay? What is our interest rate on this one? 9%. All right. So I go into my calculator again. This time I'm going to do n is 3 years times compounded monthly 12. I is 9. We are finding the present value, so I'm going to put that in as 0. I have a future value of 1,000. And again, we're compounded monthly, so down here, PY and CY, we do 12. We all feel comfortable with what we've entered? Then we go back up and we solve for present value. Alpha, enter. Okay, now is it a surprise that it comes out as a negative number? Do I write down the negative for my answer? No, and what do I round to automatically? 2, because this is like the amount you've invested in dollars and cents, right? So I'm just going to go ahead and put down that my present value, present value is $764.15. There will be some like common sense in this. Like, does it make sense that we invested less than we got out at the end? Yes. Like things like this. If you get answers that don't make sense in like their actual mind on that one, like think about it and change something. Yeah. All right. Read example. Oh, I have 2 example 9s. Look at me. On the next page, I want you to read example 9 and see if you can solve that one on your own. All right. So I've got all of this set up. We want to solve for our present value. Alpha, enter. We need to invest how much money? $17,813.92. There we go. Any issues that we're having with these? All right. The last formulas we're going to talk about today are not in our solver, and they involve the effective interest rate versus the nominal interest rate. So we're going to take a look at example 4 for this. Okay? All right, first off, and you don't really have to know this, but just because some of you want to know what these mean, this is my basic understanding of nominal versus effective interest rates. The nominal rate is like the interest rate on the face of things that they tell you. So you're getting 4% on this account or whatever they tell you, okay? So that's the interest rate that we're used to hearing about is what we would call the nominal interest rate. An effective rate combines the interest rate, so 4%, with the number of times compounded per year to basically say, if I just gave you one interest rate for the year and not even worried about compounding anything, like what would it be the same as? So like when you're converting between them, in example 4 here, we're saying we've got a nominal rate of 6% compounded semi-annually. So 6% compounded semi-annually is how many times a year? Twice, okay? So what you're doing when you're getting an effective rate, they're just saying, if I just gave you one interest rate compounded like one time a year, once, what would this be the same as?
3.
So it's actually going to be a higher one because the more it's compounded, the more money that you get, and the higher the interest rate works for you, the more that you compound. So what you're going to see is this is going to basically say over the year, you're essentially earning this percent since it's compounded more often. And so the more times it's compounded, the higher that actually goes. So what you're going to see then is a higher rate of interest when you go from a nominal to an effective. If you go from an effective back to a nominal, you are going to get a lesser rate. So where we're going to see this is not in this solver. It is, however, under the finance apps. So if you go to apps again, and you go to finance again, we're going to scroll down, okay? Actually, everyone quit first. I just made a mistake on this. Because we were in the solver, when we used the command, it would have dropped it inside the solver rather than putting it in the regular calculator screen. So if you need to use this, you need to make sure you're on the regular calculator screen first because we want our command to get dropped here, not inside something else. So it becomes very complicated that way. We will use that at some point, though. So under the finance, we're going to scroll down now, and we're going to find a command that says EFF for effective. Okay, if I keep going down, there's that one. Mine's at C. So if I hit enter with EFF, it drops it in this main calculator. And so it's essentially taking whatever you put in here and transferring it to an effective rate of interest. Now, the only thing for this one is that it doesn't tell you like what to type in and in what order, so you do have to know that. So just so that you know, this is how this command works. The EFF command, which I need to be writing here, EFF command, you need to enter I, the interest rate that you're given, not as a decimal or anything. It still does the 6%. And n, the number of times compounded per year, with a comma in between them. Okay, so that's what you have to know in order to use this command. That's all you have to know. So when I type this in then, what that's going to look like is I'm going to say 6%. The comma is above the number 7. Semi-annually is n is what? 2. So if I convert that to an effective rate of interest, it essentially says over that year, because you're compounding twice a year, you really get 6.09% interest on it. So you earn a little more the more you compound. So then the only difference between this one and B is quarterly means n is what? 4. Now, this is really where that part of using your calculator to not have to go back and find all the commands again. We all know the ability to use the up arrow and hit enter, drop it down, and just change your 2 to 4, right? If you're going to do this multiple times, it's better to not have to go back through and find all the commands and retype everything. And so you'll see here then, the more times it's compounded, the higher you're essentially getting a rate of interest over the year. So over the year, because it's compounded more times a year, you really are getting about 6.14% interest on it over the year. You can also take an effective rate of interest and convert back, which is the last thing we're going to do, and that is example 7. Okay. So if you are asked to convert back from an effective rate of interest to and find the nominal rate of interest, number one, expect it to go down because the nominal rate is less than the effective always. You can pretty much guess what you're going to use on this one because if you were scrolling through the finance thing, you saw it on the way, right? There was a nominal rate of interest. It's NOM. It's before the effective one. And it has the same commands. So you do the interest rate that you're given and n the number of times that you're compounding, and it will convert it back to that effective rate. So in order to do that, I go back into my finance menu. I go back into finance. These are so low on the list that sometimes I go up instead of down because I get to them faster. Small things. This time I use the nominal command. I hit enter. This one said the effective rate was 8%, so I use that 8%, comma, compounded monthly means what? 12 times. And it converts it back to that lower interest rate for the nominal, 7.72%. Okay. And I feel like that is enough of the different things that we need to do. You feel good about that? Yes. Okay. For the homework on this, and I'll write it down here so that you don't have to immediately find the homework and do that. I have just selected the following problems. And now it is only 10:50 in this class. I know we have a lot of things coming up this week, so I do want to give you the chance to knock out test corrections if you would like to get those done so that you don't have to think about them for the next 2 weeks. Yeah? Or you can work on your homework, but you may pick. I would at least circle the problem numbers that you need to do so that you're not home trying to do 20 questions that I don't need to do all